Franklin Stahl and Matthew Meselson wanted to prove that DNA strands separate when copying, and a new strand is synthesized through semi-conservative replication. So they tested 3 models of DNA replication: conservative, semi-conservative, and dispersive.
Conservative replication is when a double helix acts as a template for a new double helix. So the old strands stay together, while the new strands also stay together. Semi-conservative replication is when the 2 strands of DNA separate, and each strand acts as a template for the synthesis of a new strand during replication. The replicated double helix consists of 1 old strand and 1 new strand. Dispersive replication is the alternating pieces of the old strand with pieces of the new strand on each strand of the newly formed strand of DNA.
Stahl had the math skills and experience to help Meselson design the experiment. Stahl and Meselson invented a new technique, density gradient centrifugation, to separate molecules based on their density. This is their technique. First, they started growing E. coli in a 15N medium, which is a heavy isotope of nitrogen. The DNA that was synthesized had a heavy density. This is shown in the diagram on the left. Also, they grew E. coli in a 14N medium, which is a light isotope of nitrogen. The DNA synthesized had a light density. This is shown on the diagram in the middle. Next, they moved the bacteria that was in the 15N medium to a 14N medium. The DNA that was synthesized had an intermediate density, which means that it is between the heavy of 15N and the light 14N densities. This disproves the conservative replication model because that model would produce 1 light density DNA and 1 heavy density DNA. Their experiment produced 1 intermediate density. This proves that the semi-conservative replication could still be correct because the DNA molecules consist of 1 15N DNA strand and 1 14N DNA strand, producing an intermediate density. After 2 replication cycles, 2 densities of DNA were observed, an intermediate density and a light density. This directly proves that only the semi-conservative replication model could be correct because half should be 15N, 14N intermediate density DNA, and the other half should be 14N, 14N light density. And this is exactly what happened in this experiment. That is shown in generation 2 on this diagram. Even though they still didn't know how DNA replicates, they are a step in the right direction. They published the results that confirmed that Watson and Crick's prediction about semi-conservative replication of DNA were correct.